In this session, we are going to discuss about the properties of complex numbers. First, let us see the property of conjugation on addition of two complex numbers. That is, z1 plus z2 the whole bar is equal to z1 bar plus z2 bar. The meaning here is, if we take two complex numbers and if we add it, and after that if we take conjugate to that, the same effect will occur in this way also. That is, taking the first complex number and its conjugate, then taking the second complex number and its conjugate. After that we are adding that both are equal to one another. That is the meaning of the property. Right, let us try to prove this property. Right, let us consider z1 is equal to a1, that is a plus ib, and z is equal to c plus id. Then you know that very well. Then z1 bar will be equal to a minus ib and z2 bar will be equal to c minus id, because for conjugation you know that you have to change the sign of imaginary part. Now let's try to prove this. Let's take the left hand side, that is z1 plus z2 the whole bar. So for z1, let's write this a1 plus ib1. For z2, let's write this c plus id, that is a plus ib plus c plus id. So just let us do one thing. Let's make the real part together and the imaginary part together. Then the answer will be a plus c plus I into b plus d. Now we have to take the whole bar, that is we have to change only the imaginary part sign. Then the answer will be a plus c minus I into b plus d. This is our answer for the z1 plus z2 the whole bar. Let us try to do some changes, small changes in this. Let's see what is happening there. Make this minus I to go inside, so it will become minus ib and minus id. Then we can write this as a minus ib collecting these two together, then c minus id collecting these together. If you see this a minus ib, here you can find this a minus ib is nothing but z1 bar. So instead of this we can write z1 bar, and for the c minus id we can write that as z2 bar. So this can be written that as z1 bar plus z2 bar. So now we have understood z1 plus z2 the whole bar can be written as z1 bar plus z2 bar. Similarly, please try to prove z1 minus z2 the whole bar is equal to z1 bar minus z2 bar. Right, now let's go to C, the next property on the conjugation on multiplication. Again we have to prove z1 into z2 the whole bar is equal to z1 bar into z2 bar. For that also we are going to consider z1 as a plus ib and z2 as c plus id. Then its corresponding imaginary conjugations are z1 bar, that is equal to a minus ib, and z2 bar is equal to c minus id. Now let's take the left hand side, that is z1 into z2 the whole bar. So just simply write for z1 a plus ib, and for z2 c plus id. Now we have to multiply like this: ac, then plus iad, then plus ibc, then plus into plus plus I into I square, b into d, bd. So instead of I square we have to write minus 1. So the answer will be like this, that is ac plus iad plus ibc plus I square bd. Instead of I square I have written minus 1, that is simplified as minus bd. Now again we have to bring the real parts together and the imaginary parts together, and let us try to take I commonly outside. So your answer will be like this. This is the z1 into z2 value. Now we have to take bar for this, that is we have to take conjugate for this complex number. This is a complex number. For this complex number we are going to take conjugate. For that we have to simply change the imaginary part sign. So your answer will be ac minus bd minus I into ad plus bc. This is our left hand side answer. Now let's try to prove this from the right hand side. Right hand side is Z1 bar into Z2 bar. Z1 bar value, you know that A minus IB, and Z2 bar value, you know that C minus ID. We are going to multiply this in this ordinary way. If you simplify it, you will get the same answer. So it is confirmed Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar. The meaning is if you want to take conjugate for two complex numbers on its multiplication, there is no need of worrying. Take the first complex numbers conjugate and then take the second complex numbers conjugate and multiply it. Both will give the same answer. Now let us move to the division of conjugation of complex numbers. Here we are not going to do the problem as before. Let us try to do a small technique. That is, we have to prove Z1 by Z2 the whole bar is equal to Z1 bar by Z2 bar. As usual, the same Z1 value, Z2 value, Z1 bar value, Z2 bar value. But we are not going to use these values. Instead of it, we are going to do a small technique. Listen here. Just see whether this statement is correct or wrong. Z1 by Z2 into Z2 is equal to Z1, because Z2 and Z2 will be cancelled. So this is a small technique. Z1 by Z2 is some complex number, and we are going to multiply this particular complex number with Z2, then surely we'll get Z1 because Z2 are cancelled. This is a small technique. Now what we are going to do, let us take conjugate on both sides. Right, simply take conjugate on both sides. So now Z1 by Z2 into Z2 the whole bar is equal to Z1 bar. We are taking conjugation for both the sides, for the left hand side as well as for the right hand side, so the value will not change. Now we know a property, that is Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar. That means we can split this conjugation in this manner. So we are going to do the same thing. This Z1 by Z2 is our one complex number. This Z2 is our another complex number. So if we split it, we will get in this way. That is Z1 by Z2, this complex numbers whole bar into this complex numbers bar. In this manner we are splitting it. That is Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar. So this complex numbers whole bar and this complex number whole bar, like that, it is split. This is equal to Z1 bar, the same thing. Now what we are going to do, if this multiplication goes that side, it will become as division. So Z1 by Z2 the whole bar is equal to Z1 bar by Z2 bar. So we have proved this in a different way. This is very easy to prove this. So this technique you must keep it in the mind. That is the very important thing. Now let us try to understand one more thing, that is how to take conjugation for a conjugation, that is conjugate to a conjugate. That is very simple. Let us consider this equation, that is Z bar the whole bar is equal to Z. That is called by the name for this complex number. We are taking first conjugation, after that again we are taking the second conjugation, that is conjugate to that conjugate. So let's try to prove this. It's very simple. Let us consider complex number, that is Z is equal to A plus IB. If you take conjugate for this, you know that very well you have to change the sign of the imaginary part. So plus I will become minus I. Again try to take conjugate on both sides. So for this Z bar we are taking the whole bar. So here if you take the conjugate, the rule is to change the sign. So if you change the sign of imaginary part, then it will become minus I will become plus IB. So this, know that from the beginning, that is A plus IB is nothing but that is Z. So now instead of A plus IB, we can write this A plus IB as Z. So our answer becomes Z bar the whole bar is equal to Z. So till this lesson we have studied the properties of conjugation. So I request you to practice these problems try to do, that is addition, that is Z1 plus Z2, subtraction Z1 minus Z2, multiplication Z1 into Z2, and for division Z1 by Z2 I want you to do. Moreover, verify all the four properties, that is Z1 plus Z2 the whole bar is equal to Z1 bar plus Z2 bar, then Z1 minus Z2 the whole bar is equal to Z1 bar minus Z2 bar, then Z1 into Z2 the whole bar is equal to Z1 bar into Z2 bar, and Z1 by Z2 the whole bar is equal to Z1 bar divided by Z2 bar. If you practice this, all these things, it will be very much helpful for your next class. Thank you.